Hello everyone, welcome back to Learn to Code in Python. So today is day 7 in our 4-month interview prep plan. As you know, we have started this week preparing a few array related problems, and today is the last day for array topic in our data structure and algorithm preparation. Well, so for that reason I have selected a couple of interesting problems to solve. We'll finish this today and we'll start with a fresh topic tomorrow. So first problem which we are trying to solve today is Sudoku solver. First up, let's break down the Sudoku solver problem. So given a partially filled 9 cross 9 Sudoku grid, our goal is to complete the board so that every row, every column, and then every 3 cross 3 subgrid has exactly 1 to 9 digits, only once. So this is the input board which we'll be getting, which is having some numbers filled, and our target is to get the numbers filled, all of these numbers filled. And we will be using a hybrid approach to solve this. Primarily you can use backtracking to solve it quite easily, but we'll be using a hybrid approach so that will reduce the time complexity. Let's dive right into the solution what I've come up with. So first what we are going to do is, for each cell, for each unfilled cell, we are going to find out the possible values. So what we are doing by this is, we are going to figure out the values on, we are going to go to each and every cell and we are going to remove the, we are going to take out the value which cannot be there on that particular cell. So that is what this get possible values function does. Basically it will figure out the possible values which could be present in that particular cell, and after we do couple of loops of this getting the possible values, what we are going to do is we are going to switch to the backtracking technique. So let's use a simple visualization which will show how this logic works end to end. So I've created the simple visualization for the exact board which we're seeing in that other window. So as you can see, the first first step of this will be to figure out all possible values. So here in the first cell, 1, 2, 4 are the possible values because we were able to take out the numbers which are already there in the subgrid or on the row or on the columns. So as you can see, this number of possible values, if it is greater than 1, then we may need to solve that particular block by using some backtracking. But if it is equal to 1, then you can finalize this value as is, because there is no other possible option for that particular cell. So I am doing this figuring out possible values 3 times to make sure to fill in as much as possible fields through the single recursion loop. So basically 81 iterations, 9 into 9 iterations will make sure this board is filled as much as possible. After the first 3 steps, I can still go ahead and do the recursion, but I can still recursively try and figure out whether a particular value is matching or not. It might work fine for easy Sudokus, but in some cases you might need to rely on the backtracking. So how backtracking works is, so now after the 3 initial loops, I am freezing the values whatever I was able to figure out in this backtracking board. So now what I'm going to do is, I'm going to put all the possible values in each and every field and backtrack. So for example, in this case, 1, 2, 4 are the possible values, and if I try to check the possible values, it is taking out 1 and 2. So we'll start with 4. That is the only possible value it can be on this. So we are going to put each and every possible value in each and every cell, and we are going to move forward. So next, since 4 is already covered, then only possible value is 9, so that is what is going to be filled. And same way, since 4 and 9 are already covered and 2 is already covered, only 1 is the only possible value. So we'll do this filling the possible values as and when on each and every empty cell. And if we notice, like if we, in this case I put 5 here, and if I put 5 and if I put 1, it's not working. So that is, the solution is not arriving. So that's why we are backtracking to that previous version, and then we are changing it to 9. So this backtracking technique will make sure to fill the entire board. And since we are resorting to the backtracking at the end, we are getting better time complexity than the version of Sudoku solver which does plain backtracking. So this is the overall high level solution I've come up with for the Sudoku solver, and let's just have a quick view of the code, how it is written. As I mentioned, first 3 loops are logic to fill the possible values. So we'll just iterate and we'll just fill the possible values on the board. And then if no single, if at all in the first 3 loops we don't see any single numbers, and we basically break, because it doesn't make sense to do one more loop because we don't have single values, so we'll not get different results. And then the step 2 is to resort to the recursive backtracking. Basically we will use the solve function and we'll pass the board, and for each and every possible value we will place that value in the board, and then we'll try to solve the board in through a recursive function call till we get the value as true. And if at all, if you're not able to find a possible value, if at all the Sudoku is incorrect, the input is incorrect, basically you will return it as false. So, and the get possible values function is simple and straightforward. We just go by row and column and then 3x3 grid and remove the values which are already there in this 3 sections, and then we get the possible values. So that is a simple and straightforward logic I came up with for the Sudoku solver. And I did submit it, and let's just try and see. Yes, and I did submit it, and it was okayish kind of an time complexity. To take this a step further, I will try and I can try and check for the possible values which are, a lesser number of possible values. I can try and fill those fields and then move forward. That will reduce the time complexity even further. But so far I just wanted a working version and close this problem. So next interesting problem which I took up today is the text justification. So text justification is a simple problem. Given a text, like you are given an list of words separated by spaces, all we need to do is we need to give a justified, fully justified paragraph. So it means this is a standard functionality you have in your Microsoft Word or in any other text editor. So full justification means basically you will need to fill the spaces evenly across the words in each and every line. So to solve this problem, I've come up with an interesting approach. Basically, I am going to loop through the list of words and till I reach the maximum width which is requested on the input. And if I reach the maximum width and if it is equal to, then I just return that line as is. If it is greater than, then I take the next, I take the last word and move it to a next line and fill in the remaining spaces across between the words which is there in the current in the current line. So to visualize this better, I have come up with this visualization on this. So for example, this is the text which you have got. So science is what we understand well enough to explain a computer. So on the first step, what we do is we get the science, we are adding it into our current line, and then we are adding is to current line, and then what to current line. And now since the next word, when we add the next word, it is exceeding the maximum width. So now we'll try to distribute the space, and since it's actually matching the 16, so it is coming on the same line. Now next word is we, and then understand, and then the next and now it is exceeding the 16 character limit. So now again we'll try to distribute the space in the single single gap between these two words. Now it is coming up like this. So we iterate this till we reach the end of the line, and that's how we are able to get a justified, fully justified list of paragraph. So now we'll just have a quick peek on how this works. How this is written in the code. So as I mentioned, I am doing a loop on the list of words, and I'm setting the current string as empty. If the current string is empty, then we'll assign it to word, and if it is contains something else, we'll add that to the current string. I'll do a word to the current string. So if the length of the current string is greater than the max width, then we are going to apply the logic of distributing the spaces across the current words. So what I'm doing is I am taking the current words, I'm taking the current string and getting the list of current words, and I'm putting the next to last word on the current string to a next word, and I'm distributing the spaces between the words in the current line. So this will cover majority of scenarios, and on the edge case scenario, on the final line. So if we have the final line might have less than max width of characters, so the number of characters on the final line might be very less. So that's where we are doing this. So if at all, if the current string's max width is, the last line's max width is equal to the max width which is requested, then we just append it. If not, we give spaces to it. And if at all, for some reason in the loop, we are adding a space at the end, right? So if at all, for some reason, if you are getting an additional space, we are stripping that additional space. So that's how I'm handling the edge cases. And let's just see the solution submitted, and it was accepted. So that concludes our two problems which we wanted to cover today, which is quite interesting and advanced array problems. So we will come back tomorrow with a new topic and a list of problems to solve on that topic. And if you do find this video helpful, please do like and subscribe. And if you want me to cover a specific problem, please do mention that in a comment, and I will pick it up in a future video. And thanks for watching, and happy coding. See you in the next video.